Welcome to this video. In this video, we will look at how we can containerize a .NET Core Web API and how we can push images to different types of container registry using Azure DevOps. I will demonstrate with Docker Hub, Azure Container Registry, Elastic Container Registry, and Artifact Registry. Before we are going to start, we need to install Visual Studio and Docker Desktop in your local machine. Also, we need Azure DevOps, Docker Hub, Azure, AWS, and Google Cloud subscriptions. First, we will create a .NET Core Web API project with a Dockerfile, and we will push the code into Azure DevOps repository. Then we will push the image to Docker Hub, Azure Container Registry, Elastic Container Registry, and Artifact Registry. First, we will create a .NET Core Web API project with the Dockerfile. Open Visual Studio. Select Web API template. Project name. Next, we are going to use .NET 7. Enable Docker. Docker OS Linux. Then create. Project is created. It's asking for starting Docker Desktop. For debugging in a container, we need to run Docker Desktop. Docker Desktop is started. We will check the Dockerfile. This Dockerfile is used to build and run a .NET 7 web application. The first section defines the base image as .NET 7. It set the working directory inside the container to app and expose the port 80 and 443, which are commonly used for HTTP and HTTPS. This section set up the build stage. It used SDK7 and set the working directory to SRC. It copies the project files to the container, restore the .NET package using .NET Restore, and copy the remaining source code. The working directory is then changed and the application is built using .NET Build. The -C release flag specifies the release configuration, and -o/app/build flag set the output directory for the build artifacts. This section set up the publish stage. Based on the previous build stage, it uses the same build image and set the output directory to app/publish. The .NET publish command is executed to publish the application. This section set up the final stage for the runtime image, and it will copy the published output. The entry point instruction specifies the command to run when the container starts. In this case, it executes the .NET command with the DLL. This default controller created by .NET Web API template. We will run the application using Docker Desktop. It will take few seconds. Now our application is running. We will try to execute default API. Next, we will check the Docker Desktop. Inside the container, you can see one container is created with the project name. You can see container name, image name, status, ports, and started time as well. Inside the container, you can see logs. Under the inspect tab, you can see environment variable and ports. Next, we will check image. One image is created with the project name. You can see tag, image ID, created time, size as well. We will push the code into Git repository using Visual Studio. Log into Azure DevOps account, create Git repository, select Azure DevOps, select account, select organization, project, and repository name. Click create and push button. Now code is pushed into Git repository. Open DevOps portal, select repository. You can see the newly created repository. Select the repository. All the files are uploaded. In this section, we can check how we can push the images to Docker Hub. Open Docker Hub portal. Create new account in Docker Hub. Enter username, email, and password. Login. For time being, we can use free plan. Verify email account. Create new repository. In free plan, we can create only one private repository. Provide the repository name. Create. Now, repository is created. For pushing images to container registry, first we need to log into container registry from Docker desktop. For that, we can use Docker login command. Docker login, username, password, login succeeded. Next, we need to build the code. Change it to source code folder. Docker build command is used for building images. The -t flag specifies the name and a tag for the image being built. In this case, the image will be tagged as Sparrow Node / Core Web API with the version v1. The format is repository / image name :tag. The -f flag is used to specify the path to the Dockerfile to be used for building the image. In this case, the Dockerfile is located at sparrownode.webapi/Dockerfile. The dot at the end of the command indicates the build context. It specifies the current directory should be used as a build context. The build context includes all the files and directories in the current directory and its subdirectories. Execute the command. It will take few minutes. Build command is completed. Next, we need to push the image into container registry. For that, we can use Docker push command. Docker push local image name. It will take few minutes to upload the image. Push command is completed. We can check the local images by using Docker images command. You can see the newly created image. We will check the Docker Hub. Refresh the repository. You can see one more repository is created and named as Core Web API. You can see push command with the image name. We will check all tags. Under the tags tab, you can see v1 tag. Free plan, we can create only one private repository. That's why newly created repository is public. Next, we will check how we can build and push the images using Azure DevOps. Before we are going to create the pipeline, first we need to create a service connection for GitHub repository. Go to project settings. Under the pipelines, you can see service connection link. Create service connection. Docker registry. Next, select Docker Hub. Enter Docker ID and Docker password. Then verify. verification is succeeded. Next, provide a service connection name, then verify and save. Now, service connection is created for Docker Container Registry. Go to Pipelines, create new pipeline, use the classic editor, select project, repository, and branch. Click Continue, select empty template, provide a name, change agent specification to Ubuntu latest. Next, we will add task. First, we will add a task for build image. Search for Docker, add, change the display name, select task version. Next, we need to select container registry type. Select container registry, select service connection for Docker Hub. This service connection we are created earlier. Next, we need to provide image name. By default, it will show repository name and tag as build ID. We need to add Docker ID as well. Uncheck use default build context and clear the values. Now build task is completed. Next we will add a task for push the image. Change the task version, change the display name, select registry type, select service connection, change the command into push, change the image name with Docker ID. Next we will try to save and queue the job. Job is queued. It will take few minutes to complete the job. Now agent job is completed. We will check the Docker Hub. Refresh the repository page. You can see new image is created with the project name. Under the tags tab, you can see one tag is created with the build ID, that is 32, and also you can see the pull command as well. Next we will check the agent job. Under the build task, you can see one image is created. That 32 is our build ID. You can see the Docker push command with the image name. Next, we will create a image with the latest tag. In Docker, the latest tag is commonly used to denote the most recent version of a Docker image. It is a way to label and identify the latest version of image within a repository. The latest tag is not a mandatory, but it is used as a convention rather than a requirement. It is a common practice to tag the most up-to-date version of an image as latest for easier reference and to indicate that it is the recommended version for general use. Next, we will create a task for pushing latest tagged image. Clone the existing push task, rename the display name, change the image name with latest tag. Save and queue. It will take few seconds. Job is completed. We will check the log. In build task, you can see one more image is created with the latest tag. In push task, you can see push command with the image name and build ID. In push latest task, you can see image name with the latest tag. Next, we will check the Docker Hub. Refresh the page. You can see two tags is created. One is build ID, another one is latest. We will run the job again. Job is completed. Refresh the repository. You can see one more tag is created and latest tag is updated. Next, we will run the image. For that, first we need to pull the image from the container registry. Copy this command, paste, and execute this command. It will take few seconds. Now image is pulled. We can check the pulled images by using Docker images command. You can see the latest tagged image. Docker run command is used for running the container. Docker run, then name, we need to provide the name, then environment variable. Next we need to provide the port, then we need to provide the image name. -t stand for background. We will open the application in browser. Now application is loading. We will check the Docker desktop. The container is created. We will check the log, inspect. Under the inspect tag, you can see the ports. Port 80 is bounded, but port 443 is not bounded. That means HTTPS we didn't configure. We will check how we can configure HTTPS. I am not going to detail. We can follow this documentation. First, we need to create local certificate. Copy this command. Remove the credential placeholder. Give a password. Execute. Certificate is already present because we already run the application using Visual Studio. Next, we need to trust the certificate. Copy. Done. We need to run the image. For that, we will copy this command and we will do the changes. Set ASP.NET Core environment variable as development. Next, we need to set the port 80, then port 443. Next, we are setting ASP.NET Core URLs, that HTTPS and HTTP. This configuration allows the application to access both HTTP and HTTPS request. Next variable for HTTPS port that we are setting as a 8001. Next we need to set the certificate password, then default path. Then we need to specify the image name. Overall, this Docker command run a container with specified environment variable and port mappings. It is configuring an ASP.NET Core Web API application to run in a developed environment, accept HTTP and HTTPS connections, and use a specific certificate file for HTTPS communication. Run the command. Open the application in browser. Application is running with HTTPS. Next, we will check the container. Inspect tab. We can see the variables. You can see 443 is bounded to 8001 and 80 is bounded to 8000 port. Next, we will create an Azure Container Registry and we'll try to build and push the images to Azure Container Registry. First, we need to create an Azure Container Registry. Go to Azure portal, create new resource. Under container, you can see container registry, create, select subscription, then select resource group, name for container registry, select a location, select SKU. I am going to select basic. Next. Create. It will take few seconds. Now resource is created. Go to resource. This is the overview page. Under the services menu, you can see repositories. Right now, we don't have anything. Next, we need to log in with the Docker desktop. For that, we need to enable admin username and password. Under the settings menu, you can see access keys. By default, admin user is disabled. Enable the checkbox. You can see the username and password. Go to command prompt, Docker login. Next, we need to provide login server name. That's we can get it from Azure portal. It will ask for username. We can get it from Azure portal. Then password. That also we can get it from Azure portal. Login succeeded. Next, we will build the image using Docker build command. We need to provide image name with the login server URL. Then Docker file path. Build is started. It will take few minutes. Now image build is completed. We can check image using Docker images command. You can see the newly created image. Next, we will push the images to container registry using Docker push command. Docker push sparrow.cr .azure ecr.io/elearn:v1. It will take few minutes. Now it's completed. We will check the container registry. Go to Azure portal. Under the repository, you can see new repository is created. One tag is created with v1 name. Next, we will build and push the image using Azure DevOps. Go to DevOps portal. We will clone the existing pipeline. Change the pipeline name. Change container registry type. Select Azure Container Registry. Select Azure subscription. We need to authorize. It will ask username and password. Next, we need to select container registry. Next, we need to change the image name with the login server name. The same thing we need to do in the push task and push latest task as well. Now we will try to save and queue the job. It will take few minutes. Job is completed. We will check the task. Images is created with two tags. One is 35, another one is latest. You can see the push command as well. Next, we will check the repository. Go to Azure portal. You can see new repository is created with our project name. Also, two tags are created. We can connect Azure Container Registry using username and password as well. We can get username and password from Azure portal. First, we will clone the existing pipeline. Change the name. Change container registry type. Select container registry. New service connection. Select others. Provide Docker registry. We can get it from Azure portal. Then Docker ID and password. Provide service connection name and save. Select the newly created service connection. The same thing we need to do in push and push latest task. Save and queue. Job is queued. It will take few minutes. Job is completed. We will check the repository. You can see new tag is created and latest tag is updated. Elastic Container Registry. In this section, we will look at how we can build and push the image in Elastic Container Registry. Log into AWS console. Search for Elastic Container Registry. Get started. Create repository. Visibility private. We need to provide a repository name. Rest of the settings keep as it is. Create repository. Now repository is created. We can check the repository. You can see the URI for the repository. We need to install AWS CLI for connecting Elastic Container Registry from Docker. We can get the package from AWS official site. Download the package, install. Installation is completed. Verify the CLI. Go to command prompt, AWS. CLI is installed successfully. Next, we need to log into ECR. For that, we need to create an IAM user. Go to AWS console. Search for IAM. Click on IAM. Users. Add user. We need to give username. To grant an IAM user access to an Elastic Container Registry repository, we need to attach an IAM policy that allows the necessary permissions. Click on Attach Policy directly. Search for Amazon EC2. You can see Amazon EC2 Container Registry Full Access policy is listed below. Select on that. Next, create user. User has been created. You can see the attached policy. Next, we need to create access key. Under the Security Credential tab, you can see access key. Create access key. Select application running outside AWS. Next, create access key. Now, access key is generated. We can download the CSV file. Next, we will try login with this newly created access key. Go to PowerShell, AWS configure, access key ID. Secret access key. Then region and output format. AWS configuration is completed. Next, we will try to log in. Go to AWS console. Click on View Push Commands. Click on Windows. We need to follow this step for pushing the image. First, we need to retrieve authentication token and authenticate with Docker client to our registry. Copy the command. Go to PowerShell. Execute. Login succeeded. Next, we will build the image using Docker build command. Execute. It will take few seconds. Build is completed. Next, we need to tag the image for pushing to the repository. We can use Docker tag command. We can check the image by using Docker images command. You can see the newly created image. Next, we will push the images to newly created AWS repository. For that, we can use Docker push command. It will take few seconds. Push command is completed. We will check the images in repository. Go to AWS console. You can see new image is created with the v1 tag. Next, we will try with Azure DevOps. Go to Azure portal. We will create a service connection for AWS. Project settings, service connection, new service connection. Here, AWS option is not available. We need to install AWS plugin for Azure DevOps. Go to Marketplace, search for AWS. You can see AWS Toolkit. Select Get it free. Select Organization and install. Back to DevOps portal. New service connection. Now you can see AWS option. Click Next. Provide access key ID, secret access key, give service connection name and save. Next, we need to create pipeline. New pipeline. Use classic editor. Select source. Continue. Give a name for pipeline. Change agent specification to Ubuntu latest. Next, we will add the task. Search for Docker. Change the name. Change the command. Change image name with ECR URI. Select latest tag. Uncheck build context. Clear the values. Now build configuration is completed. Next we will configure ECR push task. Add. Select AWS credential. This credential we created earlier before creating the pipeline. Select AWS region. Enter source image name, source image tag, target repository name, target repository tag. We will add one more task for latest image. Clone the task. Change source image tag and target repository tag. Next we will save and run the job. Job is queued. It will take few minutes. Job is completed. We will check the logs. In build task, you can see two images. Next, Docker push with build ID and Docker push with latest. Next, we will check the repository. Go to console. You can see two tags is created. One is 44 and another one is latest. We will try it once again. Build queued, build completed. We will check the repository. You can see one more tag is created with the 45 and latest tag is updated. Artifact Registry is a service provided by Google Cloud Platform. This session, we will look at how we can build and push the images into GCP Artifact Registry. Go to GCP console, create new project, enter project name, create. Now, project has been created. Next, we will create Artifact Registry. Search for artifacts. You can see Artifact Registry. Select. Before we are going to create, we need to enable Artifact Registry API. Enable. You can see the plus button. Click on that. Provide repository name. Format is Docker. Mode standard. Location type region. Select region and create. Repository has been created. Right now, we don't have any images inside the repository. We need to create a service account for connecting registry from Docker. Search for IAM. Click on IAM. Select service account. Create service account. Provide account name. Create and continue. Next, we need to grant access. Select a role. Under Artifact Registry, you can see Artifact Registry Writer. Select, continue, and done. Service account has been created. Next, we need to create key. Click on Keys, Add Key, create new key, select JSON and create. It will download a private key JSON file. We will open the file. It contains all the credential information. Next, we will try to build and push the images from Docker. For that, first we need to log into Docker. Go to command prompt, Docker login. Username we will give as _JSON_key. Password we will take it from JSON file. Then registry URL. Basically, registry URL is region, then docker.pg.dev, then project ID. Next, credential file name. Execute. Login succeeded. We will build the image using docker build command. Repository URI / image name, then tag. After that, we need to provide Docker file path. Execute. It will take few minutes. Build completed. We can verify the image by using Docker images command. You can see the newly created image. Next, we will try to push the image. We can use Docker push command. Execute. It will take few minutes. Image has been pushed. Next, we will check the repository. Go to GCP console. You can see new image is created. You can see the tag name and Docker pull command as well. Next, we will try with the Azure DevOps. Go to DevOps portal. We will clone existing pipeline. Select Docker Hub pipeline. Clone. Change the name. We need to change the service connection. For that, first we need to create a GCP service connection. Manage. New service connection. Select Docker registry. Select others. Provide Docker registry URI. Then Docker ID. Password we can copy from JSON file. Provide a service name. Save. Back to pipeline page. Refresh. You can see the newly created service connection. Select. Change the image name with the artifact registry repository URI. Same thing we need to do in other two tasks as well. Save and queue. Agent job queued. It will take few minutes. Job is completed. We will check the logs. Under the build task, you can see two images are tagged. Under the push task, you can see Docker push command with build ID as tag. Under the next task, you can see the latest tag. We will check the repository. Go to GCP console. New image is created. Also, it has two tags. One is build ID and other one is latest. We will try to run it again. Queued, completed. We will check the repository. New tag is created and latest tag is moved to newly created image. I hope everyone understood this session. If you have any question, please put them in the comment section below. Thanks for watching.